Welcome, everyone. My name is Mark Hughes, and I am part of the team at Advanced Assembly in Aurora, Colorado. With over 15 years of experience, we are proud to be the original quick-turn PCB assembly industry leader. I'll be your host today, and I would like to thank everyone for taking time out of your busy day to join us for this webinar. For your convenience, we will record this webinar and post it on our YouTube channel in the next day or two. Several of our customers asked us to teach them more about solder, so we prepared this webinar to fill that request. We are here to listen to your needs, and if you have any other requests for future webinars, please let us know via chat. As we move through the webinar, please ask your questions in the Q&A box, and we will answer them either as we go along or at the end of the webinar. You've already met me, so let's get to know our other presenters, Shane Sheffield and Sebastian Weber of Advanced Assembly in Aurora, Colorado. Shane Sheffield is the Executive Vice President of Sales at Advanced Assembly. He's been with Advanced Assembly for 13 years and has worked on every machine and in every process at one point or another. Shane?
Thank you so much for taking a little bit of time out of your schedule today to spend a few minutes with us. Hopefully, we can share some informative information with you today about a few processes that we use here, certainly in regards to solder and stenciling and really how we're getting your parts onto your boards. We hope hopefully we can provide you with just a little bit of information that you find valuable.
Sebastian Weber is a process engineer at Advanced Assembly. He spends his days problem-solving customer designs and maintaining machines on the production floor.
Hello, everyone. So I'm a process engineer at Advanced Assembly. I've worked in pretty much every department at AA, with the only exceptions being sales and accounting, for obvious reasons. I interact and prevent issues on the floor all day, and one of my main focuses is helping provide feedback to customers to help improve the manufacturability and the overall structure of a design.
Our presentation today is focused on solder. We'll begin by discussing solder stencils and talk about our jet paste printers are revolutionizing the industry. And as an added bonus, if you stay through to the very end, we'll let you know how to get a free Advanced Assembly calendar for 2020.
So I'll start off. Let's talk about what solder is. So what is solder? Solder is a metal alloy that creates a mechanical, electrical, and thermal connection between pads and parts. It's basically the glue that holds everything together on an assembly. It is the end-all, be-all, what makes everything work on pretty much any design. There are a bunch of different types of solder, and it comes in a bunch of different mediums. The most common ones being obviously solder bars, solder wire, which most people are pretty familiar with, preformed like solder balls for BGAs and whatnot, and solder paste, which is probably the most prevalent one. All of these are used in the assembly process, but let's take a closer look at solder paste. So solder paste is like a Wendy's Frosty. It's not a solid, it's not a liquid, it's a solid. It's very similar to peanut butter, but unlike a Frosty, it actually comes in a bunch of different flavors like leaded, lead-free, no clean, and numerous different sizes or types. You can actually see some of the types on the screen here. You can see type 3, type 4, type 5. The larger the type, the smaller the solder balls are. And this magnification it's really magnified, probably 40 or 50 or probably even higher than that. So they're insanely small. Solder paste is made of spheres of metal suspended in flux. This is what gives them that sockwood consistency. This is also really beneficial because the flux makes it sticky, which helps hold the parts in place prior and during the reflow process. In case you didn't know, the flux in solder is very acidic, and this will react with the metals on a printed circuit board and the leads on the parts. It helps remove some of the oxidation on it to ensure that a proper wetting or connection is made between your part and the board. So after the parts have been soldered to the board, the flux has to be removed in a cleaning process that requires various petroleum products. This isn't great for the environment, but don't worry, there are lots of other alternative methods, such as no clean or water-soluble fluxes. There are a lot of other factors that go into solder paste that can affect the pasting process. The big ones, of course, are the flux type, the solder ball sizes, and the flux ratios. So your ratio of your flux to solder will also play a really big part when pasting your board. Most of those factors will actually play into the viscosity of the paste, which is what either keeps the paste on the stencil or on your board. So it's important to understand how that affects the manufacturability of a board. But let's talk about some of the other methods for getting paste onto your board. So first up is stencil technology. So stencils are basically thin sheets of metal with carefully cut holes called apertures. There's a couple different ways that they can make these. The most common one is probably laser cut. There's lots of other strategies as well for handling different types of parts. And you can see in these pictures, there's kind of a strategy on the picture already that shows this thermal pad actually being split out into multiple squares. There's lots of different types of this. There's like window painting, 5-dye, to help just make a better, one, provide good coverage, two, provide the right amount of solder, and also allow a space for gases and other such to escape during the reflow process. We'll cover which types of solder paste to use here in a minute, actually, because that's going to be one of the big ones, so I'll get back to that question. These stencils are basically laid on top of a circuit board, aligned with the pads, and then a worker or a machine will spread and squeegee the solder paste into the openings. The solder paste type is chosen based on the smallest aperture on the stencil. For example, if you have 0402s or 0201s or 1005s, those are kind of the parts that you want to use your smaller solder types on. So type 6 is especially good for like micro BGAs or 10005 placements. If you do have some of that technology in your design, you're going to want to talk to your assembly house and make sure that, one, they're capable, and two, that they know what they're doing in order to make sure they don't have assembly issues later on. After the squeegee application, the solder paste adheres to the pads, the stencil is removed, and the PCB is ready to be stuffed with components. But let's take a little bit of a closer look at the stencil technology. So after the stencil is aligned on top of the board, squeegee is run across. There are some issues associated with this process just because of the viscosity of the paste. So it's very important that the paste properly adheres to the pads to ensure that the correct amount of solder is deposited. For example, if you have those large solder balls in smaller apertures, your paste will get stuck in the aperture on the stencil, and it will never touch the pad, and it can cause all kinds of manufacturing issues later on. This can be a very manual process for someone to do, but there is also a lot of automated equipment out there that can help perform this process as well. The stencil process has been used for decades now, and it is still very prevalent in today's electronic manufacturing industry.
So Sebastian has talked to you about the stencil process and how we get it onto the solder paste onto the circuit board. A couple of those ways, and kind of burn through those images real quick. We'll back up a couple of slides. When surface mount technology really took over our industry and became the most popular way of getting parts onto the circuit board, the first thing was to figure out paste, the stencil, and then how to get the solder paste onto the board. There's a few ways to do that. As Sebastian mentioned, some of them are pretty manual. One way is to take a spatula of sorts and just take solder paste, apply it right onto the stencil that you might have aligned over a circuit board. You're not going to get this from any reliable assembly shop unless they're just doing maybe some rework. It's probably okay for a prototype with large components, but that's probably about the only time you would use that approach. A little bit more popular approach, and one that we used here at Advanced Assembly for the majority of a decade, is actually the fixture, something like the fixture that you see in the picture on the right. That's where we actually take your stencil, mount it to the fixture. Your circuit board is mounted inside the fixture. We align the apertures inside the stencil onto the circuit board, and we actually use a squeegee. Put the solder paste on top of the stencil and use a squeegee to apply the solder paste evenly across the board. And for a long time, this was efficient enough because components they weren't as small as they are today. Seeing these two processes worked pretty successfully for the majority of the first 10 years that we were in business here at Advanced Assembly, was fine. But then we started seeing really 0402s and smaller become extremely popular, micro BGAs become extremely popular. And what we identified was this process wasn't quite effective enough to produce the highest level quality for customers. So another option was the automated stencil process. This has gained a lot of popularity in the industry over the last 4 or 5 years. A lot of companies will refer to this as printing solder paste on a circuit board. This isn't printing solder paste on a circuit board. This is actually just a fancier way of using a squeegee. It is a better approach, and the reason it's a better approach is because the angle at which the squeegee applies the solder paste is consistent, the force is consistent, and the speed at which the solder is squeegeed onto the stencil is consistent. Those things, what it creates for you, the customer, is repeatability, but less reliability than some other options. We at Advanced Assembly, as parts began to get smaller and smaller, boards more dense, we knew we needed to find a better solution for customers. And so that's when we went into looking at what is the best solution for our customers. And we actually just skipped completely over moving towards the automated stencil process. And what we did is after some intense evaluation, what we settled on here at Advanced Assembly, and there's a lot of these options out there, but what we settled on is the My600 paste printer, which is coming up here in a moment. But back up one slide, please. Right there. Okay. The reason that we moved into the paste printer era is because in 15 years of placing parts on circuit boards, we have actually built at Advanced Assembly more unique designs than any other company in the world in the last 15 years. And this slide here, it just shows you all of the areas for failure in your design in your circuit board by using the stencil. Now, I don't want to scare you. The fact of the matter is that using stencils has been proven to work for a long time. But as parts, like I mentioned, as parts get smaller and smaller and smaller, we need to find a more reliable way to get high quality solder onto the circuit board. So I'm not going to read over all of these, but just a few of the areas here that the stencils can cause issues: aperture design, the aperture shape, aperture smoothness. We mentioned they're laser cut. What's the quality of the stencil? The stencil thickness plays a key role in as more and more small parts are being placed. If we talk about tooling and equipment, I talked about the squeegee a lot. The squeegee is a very important part of the stenciling process. How sharp is the squeegee? How thick is it? What angle is it being held at? A big one is squeegee wear and tear. How often is the company that you're choosing to go with, how often they're replacing the squeegee? Other things throughout that stencil process is how often is the company taking a stencil off and cleaning it? If you're placing 0402s, 0201s and smaller, it's recommended that they clean that between every single use. And I can tell you, if you're working with a lot of quick turn shops, that's not happening. So there's a lot of things here, a lot of opportunities for failure in today's technology when using the stencil. So that's why we moved towards what we felt like was the best option in the industry today, and that is the MyData My600 paste printer.
So we can go ahead and talk about some of the biggest turn time and cost concerns, and a lot of the ones that we're talking about, it directly influenced the reason why we got that My600 paste printer. Obviously, with that last slide, there was a lot of variables on there that were directly related to stencil process, basically the entire top side. But these are the biggest ones that can affect turn time and cost. So it's going to boil down to probably 5 or so that we feel is probably the biggest one, and that's panels versus singles, incorrect aperture sizes, missing apertures, high-density boards with low real estate, or making minor layout changes. And we'll dive into each of these as we go. So panels versus singles, this is basically, let's say you are supplying a board and your assembly house is providing the stencil. They make a stencil for a single, but you provide the board in panels. Unfortunately, because the boards are in panels, you cannot use that stencil on every single board in that panel. So that means the assembly house either has to break those out of the panel, which increases turn time and labor, or order a new stencil, which still increases turn time and basically turn time and cost, because they have to get a new stencil. That's at least a day, if not 2, more than likely 2. Some of this can be mitigated, obviously, if your board house or your assembly house is working with the board house, then they can make sure that their files match and they have a panel and a stencil, or the boards and the stencil match if they're panelized or single. So these are important things that you should keep in mind whenever you're going through this as well. Another one of the big ones is incorrect aperture sizes. And it's important to note that pretty much all of these are an increase in turn time and cost. And especially in the quick turn world, this can be absolutely detrimental. If you're on a tight deadline, so on and so forth, it just increases and causes all kinds of issues for the end customer. So obviously, if there's incorrect aperture sizes, for example, if the customer doesn't do a 1-to-1 ratio or a 5% reduction, you can actually cause basically insufficient solder to be deposited, which can result in a couple of different defects. You could get tombstones, you can get, this is especially prevalent on higher density and smaller designs. So if you've got 0402s, 10001s, small parts like that, micro BGAs, if you don't have the right amount of solder, you're going to get all kinds of coplanarity issues and all kinds of insufficient solder or tombstoning. And once again, if something is incorrect, obviously a new stencil can always be created, but that's going to be an extra, it's going to be more turn time and it's going to increase the cost. You can also rework all this stuff by hand. You can manually add paste, you can manually solder some of this stuff, but it's just increasing the amount of labor and increasing the amount of turn time and decreasing the repeatability and the reliability of those builds. So it's important to understand what your assembly house needs as far as aperture size and ratios for the paste files, and providing that for them as well. Another big one is missing apertures on the stencil. This one's just kind of obvious. Obviously, if it doesn't have an aperture on it, it's going to be very similar to the last one, where someone's either going to have to manually add paste, which could introduce defects, or someone is going to have to manually solder something. There are certain parts, such as bottom terminals, like BGAs, micro BGAs, LGAs, some QFNs and stuff like that. If a solder aperture is missing, it's basically you have to get a new stencil, and that's gonna once again increase the turn time. It's gonna increase the cost, and it's gonna increase the risk for making a mistake in the future. Next biggest one is probably high density and small real estate. So if you've got a really dense board and your solder stencil is very packed, you have very thin layers of metal in between your apertures, and this can cause all kinds of assembly issues. If you have a larger stencil, a lot of times when you're putting pressure down, you can make sure that pressure is maintained. However, if you have a smaller stencil, it's more likely to bend or bow, and you can kind of see in that middle picture where you could have a situation where the stencil is actually slightly bent upward in the center of the board, and it causes either more solder to be deposited or less solder. So it's very important to understand that whatever stencil technology you're using can handle the types of parts that you have on your design. Your assembly house needs to make sure that if it's got 10005s, they're taking the necessary steps to make sure that they can paste these efficiently. One of the other big ones would be minor layout changes. Go to the next slide. There you go. So obviously, especially with quick turn, sometimes you're trying to cut a deadline, you get your first article to you and you go and test it and you find out, I just made a huge mistake, I need to get boards respun, so on and so forth. But a lot of times these little changes can just be minor. It might just be a change in an IC or something like that, but enough of the footprint has changed that it requires a new stencil. And when you're under the gun like that, it's going to be, it's another risk and it's another cost and turn time add to a job that you probably don't need or want. So these are kind of the issues that drove us to looking at the MY600. Each and every one of these issues kind of gets solved by it in different aspects and different ways. And I think we could probably talk about some of that. Yep, there we go. So obviously, the stencil process has been around for a long time, and the MY600 does cover a lot of this stuff, but there have been improvements in stencil technology as well. It's important to understand that any assembly house that you do go with, you know how they're handling all of the different types of technologies. And there's different things. There's nano coatings. You can kind of see in that first picture. The water that's on there shows the roughness of the stencil. And in that third picture on the right-hand side, you can see how smooth that is. What that does is it helps make sure that paste, whenever it's pasted, is properly released into the apertures. When you have 10005 components and really, really, really small apertures, your paste is more likely to stick in the stencil than it is to stick to the pad on your board. So it's very important to look at stuff like that. So there's all kinds of stuff. There's nanoslick technology. There's step stencils, which you can see in the bottom left. This is basically to allow for different amounts of paste to be deposited at different spots by filling those up. There's jet paste printers, which we'll cover a little bit more when we talk about the MY600. There's SPI technology, which you can see on the bottom right. So SPI basically stands for solder paste inspection, which allows after you paste, you can basically get a 3D rendering of it to see if the correct amount of paste has been deposited or if there's anything that needs to be adjusted or fixed. There's also things you can do like first article process. You can run one board, run it all the way through the process, make sure that everything checks out, and then you can make those changes. You can get another stencil that way, or you can modify an existing paste printer program, so on and so forth. So there's a lot of different ways you can do this, and it's very important that you understand what your assembly house is doing to help ensure the reliability and the repeatability for your design.
So all of this and 15 years of assembling circuit boards really led us to lean on our customers a little bit more and more over the years. Two things Sebastian just mentioned: reliability, repeatability. Our customers said that's what they were looking for, in addition to high quality and speed. Advanced Assembly, specifically here, we offer what we call miracle turns. And that's basically the ability to assemble a circuit board in 4 to 5 hours. We also offer 1-day turns, same-day turns, 2-3-day turns. And a lot of other companies offer this as well. Guys, this is only possible if you aren't losing the time of ordering stencil or having to recut a stencil for any of the multitude of reasons that we've covered here. So as our customers needed things faster and faster, as components became smaller, board technology has consistently increased, we felt like we owed it to you, the customers, to go out and find the best piece of equipment possible. And so that's when we began doing our research so that we could offer yet another option for our customers. We still use stencils from time to time because there's no single solution for everything. But what we found was that the MYCRONIC MY600 jet paste printer fit all of the needs of most of the needs of our customers in today's really more technological advancements in the circuit board assembly industry. So this is a piece of equipment that we chose. And we do encourage you, reach out to your assembly shop, find out what equipment they use, find out how that equipment aligns with your needs. But Sebastian's going to go into a little bit of how we chose this piece of equipment and how we actually got that into service into our assembly process?
Yeah, so about 4.5, 5 years ago, with all of those issues that we kind of just talked about, and this is actually at running. It throws 3 Gs around, by the way. It's got a huge, some huge block underneath it just to keep it from ripping itself apart. But it's super fast, super crazy, super quick, and very accurate as well. Also, it sounds cool, so there's also that. But basically, 4.5, 5 years ago, we were looking at all of these different factors and some of those big opportunities we had just discussed, and we were trying to figure out a way to help mitigate that so we could better do true quick turn, which is those miracle day turns. It is those 1 day, those same days, even those 2-day turns. And especially when a customer has a continually evolving design, I mean, the MYCRONIC My600 jet paste printer only made sense to us because you can change those designs on the fly. You can make small little modifications. You can print and paste micro BGAs and 10005s without having to worry about the same issues that a contact printer has, such as like a STENCIL process or something like that. It basically sits above the board and shoots paste down to all of your locations. So it also can paste on assembled boards as well. So there's a lot of different advantages, and we were looking at it and it looks really cool. So we decided to give it a try, and we've tried all the other stuff. We tried the NanoSlick, we tried continually cleaning stencils, we tried step stencils, so on and so forth. And what we were really trying to do is find a better way to get this process down. So we talked to MYCRONIC. They came out here for about 6 months, and they actually tested and debugged and did all of the settings for it to function at high altitude, which has never been done before. So we were actually the first people in the business to get it up and running. The reason why we had to do that is because we're located in Denver, Colorado, so we're, Mile High City, we're a mile high up. And these printers had never worked at those altitudes before because of the viscosity of the paste and because it is done by a vacuum and by an auger. And so that's basically how it works. We specifically constantly invest in our machinery to match what our customers needs. And this was exactly the piece of equipment we needed for the direction that we were heading, which is, of course, quick turn, high quality PCBs. And we're specifically geared towards helping you figure out how to best improve this process and providing that quality up front, as well as even mid-process. So if we're going through and we figure out that we need to change the paste on something, we can do that on the fly with absolutely no issues. I think that's basically it for that part. I'll let Shane take over and talk about all the benefits we got.
So you saw in the first slide earlier was a lot of the opportunities for failure, and this will show you the opportunities, the benefits of using the paste printer. And without going into a ton of them, here's a few of the ones listed. The biggest one is changes on the fly. When customers come to us, especially in the early rev and the prototype phase, there's constant changes being made, and it's either by the customer themselves or by the assembly shop trying to figure out exactly how much paste to be applied, let's say under a BGA or a heat sink, and that's what the first article process is for. We're able to build one board completely through the process. Once it goes to reflow and X-ray, if there's any changes that need to be made, we can make those immediately. There's no delays whatsoever that the customer will have to experience when we use the paste printer. So not only can we make the change on the fly, but it's everything. All the time that's required is reduced. Setup time is reduced. The time to change during the process is reduced. Again, we mentioned this earlier, but repeatability, reliability, high quality, all of those things come along with applying the exact amount of solder every single time. We mentioned, we don't have to clean a stencil. We used to try to clean a stencil after every build, but to do that and still meet our quick turn expectations, we couldn't do it. So that no longer has to happen. So our yields improved, our amaze decreased. Not only, guys, we experienced so many benefits from having one of these machines. We actually bought a second one. So we wanted to make sure that we had plenty of redundancy through the design as we got closer and closer to capacity, that we would have the ability to continue delivering those quick turns.
And yeah, kind of just to build on that, once again, this is a machine, so there's a lot more automation that goes into it, and there's a lot more controls in this. So there are other costs as well. So obviously you still have to clean ejectors, you still have to clean filters. There's a requirement for a vacuum generator. There's regular maintenance. There's the pace time it takes is actually slightly increased, but the overall time is actually much, much quicker. There are some board size limitations and some pace limitations as well. Currently, we can only use no clean only, and it can only do solder types 3, 4, and 5. There are caveats to this, however, because we don't use STENCIL technology. You don't necessarily need like a solder type 6 on smaller ones, because we are directly pasting onto the board. We don't have to worry about that surface tension keeping that solder on the STENCIL. It will just shoot straight down and put the smallest dot where it needs to go. And to build on some of those benefits, so it's also controlled. So it allows for a RoHS control. You have to scan in your paste, so it will make sure that you don't get the wrong paste on that, which is another risk with stencils. You don't have to do any manual paste edits because you can do it all through the software very quickly. If we need to make an edit to something, we can do it in as little as a minute and a half. It also has a built-in paste inspection process. And once again, that is also automated. It's not a manual process. And it's basically fully automated. It's literally the one-stop shop for pasting for quick turn and what we do.
All right, everyone. We'd like to thank you for making it this far into the presentation and let you know about a little calendar that we're offering. This quiz that we wrote is so hard that we can't even pass it. In fact, our current success rate is at about 97%. That's 97% of people that cannot get all 8 questions correct. So if you take this quiz and all you have to do is take it, we're going to send you a 2020 calendar that you can hang on your wall that has all sorts of coupons and fun things in there that'll save you over $3,000 over the course of the year. So take a moment, write down the web address or take a picture of the QR code and send it to your friends. We are now ready for questions. So if you have any questions, please ask them in the Q&A box or the chat box. We'll try to monitor both for you. Is there anything else that you'd like to know? I know, Sebastian, we had Rob Weiss earlier that asked, how do you determine whether to use type 3, 4, or 5 solder paste? And the answer we provided him is just the rule of thumb that you need at least 5 or 6 balls of solder across your smallest width aperture. Do you have any other advice on that?
Yeah, and I'll kind of add on to that. So one of the things, obviously, I kind of touched on as well is the My600 allows for us to basically shoot paste down onto the board. So even like the solder ball size and stuff like that is less of a factor for what we do here. The biggest factor for that is how small the dot that it can shoot onto the board, which is extremely small. So we don't have to worry about issues like that, especially when we're dealing with pasting on the My600.
Thanks, Sebastian. Do we have any other questions at this time? Anything you guys want to know about solder? I know it's an exciting subject and you guys have taken 30 minutes away from your lunch break to find out about it. So let's grill these guys while we have them, yeah?
So Ben Newland asked, are there any design features that are affected when using the jet printer versus a stencil? Is there any practices that can make the jet printer easier to use for the design? So we're also very heavy on custom software here. We custom tailor to what we do to help improve how quick turn we can get. So typically what we'll ask is that whenever you're doing your paste files, your paste layer and everything else like that, we typically request that you do it at a 1-to-1 ratio so that our paste files will automatically convert those to what's needed. Additionally, we have trained paste operators that will modify layouts based off of certain types of parts. For example, micro BGAs, they already know how to handle those. Really, really strange LGA land pattern parts, they know how to modify those. Stencils cannot print circles with holes in the center for obvious reasons because there's no way to support the hole. So one of the ways that we also modify that is our paste operators are trained to modify some of the layouts so that we can paste those. For example, microphones, through-board microphones are pretty popular, or other MEMS devices. So I think that answered the question, but I kind of ranted for a little bit.
Ben, is that what you were asking, or were you trying to drill down on designing things like home plates and that sort of thing? If you can let us know, we'll try to get you more information, or if we've answered it, that's great. We also have plenty of time for more questions. So if you have any, go ahead.
Since we have some time, I'll kind of add on to that too. Yeah, if you put those types of designs into your paste layout, that's perfectly fine. We'll actually take those and use them whenever we paste it and then modify it as well. So some of what we already do is make those changes and those designs just to help improve or decrease the amount of voiding or improve the connection of your thermal. But if you already incorporate it into your design, that's perfectly acceptable. You actually don't technically have to do anything. We'll do most of the work on our side to make sure that you get the right product. And we're the experts at it, so trust us on this one.
Okay, we've got Ben's answer. Thank you, Ben. We have 5 minutes for other questions. If not, I'm going to have Sebastian rant. Is anybody would anybody like to ask a question to prevent that? Because he'll do it. We're not joking.
I'll start talking about the quiz. That quiz was definitely rough. You should have people do it. You should take the quiz and then you should send it to all of your coworkers and your friends and everything else just to force them into some of the hell that we all live into.
And I'll let you all know something, a little bit of background on that quiz. I misunderstood when we were creating that. I thought that the winners were going to get a free oscilloscope, so I didn't want too many people getting all questions correct. It turns out that the quiz, it's just whoever takes it gets a calendar with $3,000 worth of savings. So sorry about that. I hope I don't bruise too many egos. All right.
It is a cool calendar, though.
It is a cool calendar. All right, we've got no other questions. So Sebastian, let me ask you about this. You've got a pet peeve regarding uncapped vias and open vias underneath BGAs, land patterns, that sort of thing. What's the problem with that? Because capping a via is so flippin' expensive. I just never want to do it. So why is it a big deal? And why do you care so much about this particular topic?
So I care so much about it because it almost renders a board completely manufacturable, and it is a more expensive process during the board fabrication process. But I can tell you, in almost all cases, it is far more expensive to fix or to redo on the assembly process. You're also decreasing the reliability because basically what happens is your solder will thieve down into those vias, and you end up getting no connection on your BGAs, which means someone has to rework that board at least once, if not multiple times, to make sure that a connection is properly formed. So you're decreasing the reliability, you're decreasing the repeatability, you're making that board virtually unmanufacturable on the production level. So it's very important to understand that sometimes a cost-saving shortcut in the board fab world may equal issues in the board assembly world. I see a question from Paulo. Round or square rounded aperture stencils for BGA. Yes, so that is also another method for improving the stencil process. It's important, once again, to talk to your assembly house about what they do to help mitigate some of these issues. With the paste printer, we actually don't have to deal with any of that because it is depositing, it's basically shooting out balls of solder paste onto the board. We can actually change how small or how large it is with absolutely no issues. But that's definitely one design feature that you can add to your board if you know your assembly house is using a stencil to help improve that process. And once again, that's just really good communication. Get with your assembly house, talk to them about what helps them out, and I can guarantee you they will always, always, always give you good feedback to make sure that you can get the best product and they have the least amount of headaches.
All right, we've got 2 minutes remaining in this webinar. Do we have any other questions for our panelists? Well, let me go ahead and put up the contact information for Shane and Sebastian. If anybody has any questions for these guys, please feel free to reach out. You can call them, email them, whatever you like. Let us know what we can do to help you, and we'll try to do it. Something else you might be interested in, we've got software that lets us automatically run design for assembly checks and design for manufacturability checks for that matter. So even if you don't want to have your boards made with us or have your boards assembled with us, just send us your files. We can run them through the software and we'll let you know of any potential manufacturability problems that might come up in your board. It's free. There's no commitment. You don't have to put a credit card down or agree to buy anything. It's just a service that we offer because it basically takes zero time for us to do that since it's automated. And at some point in the future, we're going to try to get that on our website so you guys can just put your files there and you don't have to bother emailing.
And if you're in or around Denver, you can definitely always come down and see us personally as well. We're always open to showing off what we got, and we're pretty proud of our entire building and our assembly process.
Yep, and that service that Mark was talking about, that's called our IDFA checks, IDFA. So yes, please feel free if you just want to test out a little bit of our design for assembly process and checks. We would be more than happy to take a look at your files for you and let you know how our software sees those. But it's called our IDFA. If you do reach out to me or anyone on the sales team here, they can help you with that. But we'd be very happy to help you at any time using our software.
All right, with that, we will close out this webinar. So thank you everyone for joining us today. We'll send out a recording of this webinar in the next few days. And we're also looking for ideas for next year's webinars. If there's anything you'd like to know more about or like us to drill down into specifics of any topic at all related to design for manufacturability, design for assembly, we could do that. Anything regarding PCB fabrication or PCB assembly, anything at all, please let us know and we'll add it to our list. All right, well, thanks everyone. I'm gonna go ahead and close this. We hope you have a great day and we'll talk to you soon. Take care. Bye.